This is part 4 of unit 3 of power electronics. So in this unit we will study the quadrant operations of chopper. So there are various types of choppers such as class A, class B, class C, D and E, also known as type A, type B, C, D and E. So let us see what is the class A operation of chopper. We already know the circuit is a circuit of step down chopper where chopper is connected in series with the supply voltage. So when the chopper is on, so the supply voltage is connected to load, and when the chopper is off, the supply voltage is disconnected with the load. So the average output voltage at the load will be less than the input voltage. Here we call it as the first quadrant operation because we are taking a convention that if the positive terminal of the load is the upper terminal and negative is the lower terminal, the voltage we will take as positive. The current, if it is flowing towards the load into the load terminal, we consider it as positive. So on x-axis if we take current and on y-axis if we take voltage, so in this case both voltage and current follow the same convention that it is positive and current is also flowing into the load, so we take it as the first quadrant operation of the chopper. We already know the working of this, and the first quadrant operation of chopper is also known as step down chopper.
So let us see the class B operation of the chopper. This is the circuit diagram. Here we can see that the direction of the current will be opposite to the conventional direction of current, because note down how the diode is connected in the circuit. So when the chopper is on, the current will be flowing in opposite direction, and the source E will help in charging the inductor. When the chopper is off, during that time, voltage source E along with the energy stored in the inductor will be applied to the supply voltage V. So it will help in charging the supply voltage V, and this type of phenomena, because the voltage average output voltage is positive whereas current is negative, is known as the second quadrant operation of the chopper. Such type of a circuit is useful in the such as electrical cars, where we need, where when the brake is applied, an EMF will be generated, and that EMF will be helpful in charging the car battery. This phenomena is popularly known as regenerative braking of DC motors. Let us see what is the class C operation of the chopper. So basically this is the circuit diagram. We can see that class C operation is the combination of actually the class B and class A chopper. So first and second quadrant operation, when they are combined, can be used as class C chopper. So this is when chopper 1 and diode D2 are conducting. This is equivalent to the first quadrant operation, because in this case the output average voltage will be positive and current is flowing towards the load. So both current and voltage are positive. So this is the equivalent circuit for first quadrant operation. During second quadrant, we operate chopper 2 and diode D1. So it becomes equivalent to a circuit which we have just discussed, the class B operation. So we know that in class A operation it is first quadrant operation, and in class B operation it is the second quadrant operation. So combination of class A and class B become a class C chopper operation. So this is the waveform. Here we have to take into consideration that chopper 1 and chopper 2 are never simultaneously operated because it will short circuit the supply voltage. So it can be very dangerous. So we have to design a circuit in such a way that chopper 1 is operating in one time duration and chopper 2 is operating in a second time duration. So combination of chopper 1 plus the diode D1 will form the one half cycle, and output voltage will be positive in this case, while when D2 and channel chopper 2 are operating, during that time output voltage becomes 0. In the class D chopper operation, we have this circuit diagram where there are two diodes and two choppers connected in a bridge network. So in this case, when the channel 1 and 2 are conducting, this is the equivalent circuit. So we have output voltage and the direction of current is as shown in the figure only. So when in the second half, diode D1 and D2 will be conducting. So direction of the current flow will remain the same. Here in this case, basically when chopper 1 and 2 are conducting, the circuit is operating in first quadrant, and when chopper basically when diode D1 and D2 conduct, the voltage is negative due to energy stored in the inductor. Therefore, if the average time on time is more than the off time, during then the during that time the output voltage is positive, otherwise the output voltage is negative. This can be observed by seeing the waveform of the circuit in detail. So this is the waveform when on time is greater than off time. So we can see that both the choppers in this circuit operation are conducting simultaneously. In fact, they have the same trigger input current, gate current. So during this time, when the output voltage, since on time is greater than off time, the output voltage positive half is more than the negative half. So output average voltage is positive in this case. When T on is less than T off, the case will be reversed. Now the average output voltage is more in the negative half cycle. It remains more for the larger time duration. It remains negative. So the output average voltage is negative when T on is less than T off. So the direction of current flows remains always positive, but voltage can be manipulated as positive or negative depending on time or the off time ratios. Therefore, this output average voltage from the circuit can be in the first quadrant or in the fourth quadrant. So basically class D chopper operation has the possibility of operating in positive positive or voltage negative and current positive mode. So it is a combination of quadrant 1 and quadrant 4. So next is class E chopper operation. Now this is a circuit which combines all the four quadrant operations. So the circuit is complex. So it has basically four choppers, switches shown here as S1, S2, S3, S4, and four diodes. And with every chopper there is a parallel diode connected, and you can just note down what is the direction of diode connection in this case. If we observe that the switch 1 and 2 are operated simultaneously, so this is the direction of current flow, and voltage output will be proportional to the supply voltage Vs. So both are positive. Now this is the equivalent circuit. For your understanding, I've removed all the unwanted which are not operating in the circuit. Those components have been removed in the circuit. So when S2 and D4 are connected, the direction of current flow remains the same and the output energy is discharged through this path. So both voltage and current are positive in this operation. So this is known as first quadrant operation of the class E chopper. So the second quadrant operation of the chopper, in the first figure we can see that S2 and D4 are conductor. Current flow is opposite in this case, whereas when uh, diode D1 and D4 are conducting, the current direction is again the same, but the energy is fed from the load to the source side. So this is basically second quadrant operation of the chopper. In the third quadrant operation, when S4 and S3 are conducting, we can note down the direction of current flow is opposite, and this is the equivalent circuit. So basically, due to the supply voltage which is connected here, the direction of current flow is negative, and output voltage is also negative. So this is the circuit when DS4 and D2 are conducting, and during this time also the output voltage is 0 but the current is negative. So this is the third quadrant operation where both voltage and current are negative. In the fourth quadrant operation, D3 and D4 are conducting. This is the equivalent circuit. Now the direction of current flow is positive, output voltage is negative. The equivalent circuit, when S2 and D4 are conducting, the direction of current flows remains same, and output voltage is energy stored in the inductor is discharged using this path. So since the voltage is positive but the current is negative, the voltage is negative but the current is positive. So this is the fourth quadrant operation of the chopper. So basically, if we combine the four quadrants, we can see then when in x-axis we are taking current and y-axis is the voltage. So when both are positive, it is termed as forward motoring action. When current is negative but voltage is positive, it is forward braking. When both are negative, it is reverse motoring. When voltage is negative and current is positive, it is reverse braking. So basically, if we see this equivalent as speed and torque, so we can see that when the torque and speed are positive, so the power is generated in a positive direction because voltage and current are in a positive direction. So there is an increase in speed basically. So when the current is negative in the second quadrant, you can see that power and torque are negative. Due to this, there is a reverse braking phenomena which is taking place, forward braking phenomena which is taking place. In third quadrant, it is known as reverse motoring because speed is increasing but in a reverse direction. So in one direction, the in a forward motoring direction, the DC motor is moving in a clockwise direction. In a reverse motoring direction, it is moving in a anti-clockwise direction. So in quadrant 1 and quadrant 3, basically the speed of the motor increases. The difference is that it is increasing in a positive, in a clockwise direction in a first quadrant and in anti-clockwise direction in a third quadrant. So corresponding to third quadrant, we have a fourth quadrant where when we apply a brake, we need a negative voltage and positive current. So combination, that means in reverse motoring we can have reverse braking which is fourth quadrant. In forward motoring we need forward braking which is in the second quadrant. So basically we can operate DC to DC converters in any one of these quadrant, or as we have seen in a combination of any two quadrant, and in the last case in type E chopper we see that we can operate it in all the quadrants. So where such applications are required, basically in the applications such as trams, in pulley cars, in traction motors of locomotives, we require such operation because they don't change direction. What we do is, in a forward motoring, they will be moving in one direction, and when we want to stop it, we will apply forward braking. Then when we want to move them in a opposite direction, we will use the third quadrant, and when we want to stop it, we will use the fourth quadrant. So in such application, a type E chopper would be required, where we want to move the engine in one direction, then stop it, move it in the other direction, and again stop it. So here the quadrant operation of the chopper is very useful. Thank you.